What up, what up? Oh, I have a... 1 second. Oh, shit. Breaking my entire setup. There we go. Okay. I'm gonna have to fix the annoying screen lag. Don't know why this happened. Stop sharing. Boom, boom. I'm getting pretty fast at fixing this nowadays. We turn off show cursor. We switch the screen input. We say okay. We switch it back. We say okay, and then we turn on the cursor, and suddenly the majority of our lag is gone. What up, Alchaeus and Bad Cop? How are we doing today? All right, let me think about where I want to start this morning. I can't remember where I left off on S tier. I think we are good on S tier for the time being. I have this published and working. Let's go, we can delete that file. And let's open source index. Deserialize a string into an S expression. Good, learning how Git flow work when you aren't a maintainer on the project. Don't have to fork things often at work. Oh yeah, I love Git flow. I use Git flow for like everything. That's my preferred like branching strategy. Okay, so this looks pretty good here. Let's go look at the build quick, because it's the types that we care about, right? This is what's going to be exposed to us in our TypeScript. S tier, we get a S expression type, we get a canonical S expression type, deserialize a string into an S expression. Okay, that all looks pretty good. All right, so let's jump over to, I don't even remember what we called our project for the RPC server. So just do an RPC. Yeah, okay, so let's bun install S tier and melange FFI. So we got our 2 supporting libraries now, and let's vim into this project and look at, this can probably be a TS config. We can probably go straight up yoink the TS config from S tier. So let's do that. What the frack is this? Get out of my face, Tailscale. We're going to go to S tier and we're going to vim into this. Go grab the TS config. Hit G, come up here, Shift V, place that in. Okay, that looks good. Quit out of that, and we can kill that. Include JS, TS. Okay, that looks good. Okay, I think that's solid. What up, Shrey? What's the right way to pronounce your name, or what would you like me to call you so I can make a note? Thank you for hanging out on stream. Welcome. Right, we need to work backwards. It's Shrey, yes. All right, let me make a note that that is how to say it. Shrey, yes. Boom. All right, got my mod notes in. I will try not to, I shouldn't forget that because that's what your name's going to show up as. Yes, almost there. Shreyas Anthu. What do you want to be called? Do you prefer that, like, is that your full name, Shrey? React to video? Yeah, if you throw a video in, we will do a video react. Shreyas? Okay, cool. Yeah, chat, if I ever get your name wrong, feel free to correct me and I will make a note in like the moderator tools, and that's what shows up in my chat log. All right. Life of a Giant. Here we go. Let's mute the music. We got a react from Many Zeros 8. You have my name wrong? Ooh, awkward. Let's pause. All right, here we go, chat. We're watching Life of a Giant. I have no idea what we're about to experience, but here we go. These look like the masks from Skyrim. Winnie. 1 second. Let me go get this anxious golden retriever under control. Hey, what are you doing? No, we're not doing that. Into my office. Let's go. Go. Get in there. You don't need to be out there barking. Take a snooze. All right, here we go. This video would be horrible to watch, like tripping. Where did you find? Hey. Oh my god. I don't know. We had a video react redemption and this was the video. So this is what we're doing. Life of a Giant. I'm scared, but it's kind of beautiful at the same time. What the fuck? I'm gonna put this on 1.5 because why? How did you find this video 008? So this mall, oh, they tore it down. Big rip. Not the giant. They destroyed his home. Rip. Okay, well, that was exciting and interesting. I feel enlightened. I feel like I just lived 1,000 years. Um, beautiful stuff. Beautiful. All right. So we have our server. Let's open another window and get, I have a switch somewhere that Dune, it's just like Dune RPC installed. We want to construct an S expression. In fact, we should go see if the libraries we wrote bindings to, we should actually make this S tier because we're going to want a way to easily edit our S expressions. And right now we just have parsing or serializing and deserializing. So let's make sure, how's the font size, by the way, chat? Is this okay? Should I bump it up a little bit? We want to go to sxplib. Tad bigger would be nice. All right. Story of my life. Okay, sxplib. Where's the where is the OPAM docs for this? Come on, give me the link. Do we not have it? All right, we'll just go to OCaml.org and then we'll hop into sexpressionlib docs. Let me turn on dark reader. So we can parse. Does this give us functions to edit it though? That doesn't look like it. Parser, conv. Oh no. They're so strict about it. There has to be something in here to work with these, right? I would assume. Like I want to be able to push atoms in lists. Replace, extract, match. I want like a push. Yeah. We'll jump in here in a second. Maybe it doesn't make sense. Because we would want to parse an S expression into an object potentially. Yeah. I'm thinking about this wrong. Okay, so let's jump. Let's actually name this session. This will be our S tier window. And this will be, this will Dune RPC TS. And then we want, I need to bump down the font just a little bit. It's too big. I get random seg faults for storing shit improperly. Oof. That does not sound fun to debug. All right, so let's go make sure we, this will just be Dune. Do we still have Dune in here? Dune Playground. RPC. All right, so let's add Dune RPC, and I think we also want to add Dune RPC LWT. Yeah. Dune RPC and Dune RPC LWT. Guys, no barks. And then we can come in here and do Dune build at install. That should generate our OCaml file. What's crazy, Leo, is Zach Balin. I work with him. Really brilliant engineer and OCaml dev. In the past 2 months, he's found 2 compiler bugs in 4.14 that were like verified by Xavier himself. I'm not sure if it's pronounced Xavier, but Professor Xavier, so badass. What other programming language can say that? We have an X-Men, or yeah, X-Men leading the language. Okay, so Dune build. Great. Can we do Dune utop? I probably have to install utop. OPAM install. Get my dev dependencies in. I should just literally write a command to, or an alias to run that. Oh, cool. I already have it installed. Sick. Whatever. I don't care. Okay, so if we do Dune utop then, we should have Dune RPC in here. Sweet. Okay. So now we can play around with some of our... this is what we were trying to do for like 3 hours the other morning, is just get these libraries into the frickin' REPL. So let's go, we want to look at mostly probably the LWT client. And in here, we're going to try to replicate. We need to basically build up the so let's run this. And let's make this full screen actually. So we have this init thing. What does this end up looking like? It's abstract, of course it is. That's awesome. Let's make this next. And what do we get here? Right, that makes sense. Okay. We should also have things like our I don't know how to do any of this. Is it help? How do I clear? Is it just clear? Does this not have a clear? Okay, I guess not. So let's, what do we want to do here? All right, we're gonna try installing Dune again just so we can hop around the files. So let's clone this. Quit. Git clone. GitHub personal, paste that in. What up, robot? Not too much. Just gonna stream a bunch today, I think. I don't got much going on. Only thing I have to do at some point is run to the grocery store. So let's change directories into Dune. And should we try doing this with Nix again? Speaking of Nix, all right, so we have that. So we should be able to say make dev now. Oh yeah, we do have to do that annoying thing where we move OCaml to, the other way. That one. Okay, now we should be able to do make dev. So we'll have, for now, this one be Dune RPC, and the one to our right be Dune RPC LWT. So in our client, we want to look at this. We create an atom, S-expression atom example client. I don't know what typehero.dev is. So we should have CS expression, and if we do atom, we say example RPC client. This will be our ID. So we're gonna replicate this. Oh, I gotcha. Yeah. I didn't realize that's what the name of his thing was. So then we should be able to say CS expression.toString and ID. Okay. We can do that. This doesn't do anything too crazy. Let's see what connect chan does. We'll say, go to here, and we'll go into source. This is probably provided to us by a functor. Oh no, it's not. Oh yeah, this returns the file descriptors, right? And we return FD input and FD output. Okay, so that gives us back some file descriptors. So we then make a request where we give it the client. Where did the client come from? Am I blind? Does anyone see where this client comes from? Oh, it comes from this function here. So we get it from a callback. Okay. Pass this, and then we have this ping. Okay, so we want to first try making this request. So Dune RPC client versioned prepare request. Let's just look at what the request ping looks like. So it's going to be Dune RPC, and we'll be in here, and then we're going to look at probably in here, but bet it's in here. It'll be, do we have ping? 3 different pings in here. Okay, so we have this procedures library. So let's see if we can go find procedures. Here we go. And I bet ping is in here. Yeah, we have a couple pings. What up, Plank? V1. Does anyone know what DECL is? Ping.
Functions describe the world.
Thank you for the follow, DJ Mail Boy. Mally Boy. Declaration. Declaration.request.make. Format Doom file. All right, so when we say that v1 request, let's see what actually on the outer scope of this library, let's see what v1. So we get this v1 struct, and it calls request. And what do they say request is? Don't see that there. So it's probably included from public, right? I'm betting if we go look at the public, this is too heavy. Okay, here's public. Yep, and we get the request. So that's where that's coming from. Procedures ping is that. So if we go back to this file, we say ping. So this is actually what a request is. Okay, that's a, so procedures public ping declaration. Module declaration equals declaration. So let's look at what a declaration is. It's probably under types if I had to guess. Yep. So a declaration is some polymorphic type that gets a method version map, a universal map key, okay, All right, looks like we're playing with like some existential type stuff here, maybe. Okay. Version prepare request ping. Ping comes from procedures. Let's go back to procedures again. Procedures are here. Public ping. Request.make current gen. So we should be able to look at where we were just looking at declarations, which was this file. Declaration. Dot make current gen. What do we call, where is that at again? Let's move that over there. Request.ping. Ping.declaration. So it's this one right here. So we say declaration.request.make. And then if we go look at our declaration, which might be here, yeah, we say, oh, this is so hard to track. Here we go. Request.make current gen. We get a request, a response, and a version. And we're going to return a struct that looks like this. It's a tuple of a version, a generation.t. Is this a local open? What is this thing?
Functions describe the world.
Declaration request.make. Oh, it's this one right here. Right. generations, we make a method, we make this key, giving it a name, and int map to din, gen to din. All right, let's see if this built. Okay, it did. So let's vim in, and now we should be able to go jump through the code here more easily rather than dealing with that. Let's go to Dune. Where's RPC? Other libs, Dune RPC. And we want to look at here. And let's go to source here. Actually, we want to go up to the examples, RPC client, this one. So this is like our baseline. We want to go see this. Perfect. This returns a T. Our T is this. Okay, sweet. So we should start with, we have types of requests. So let's start making that in our TypeScript client. So this is going to be an initialize request. So let's yoink basically this whole struct, this whole module, jump back over here, and let's make a source directory. Okay, and we'll say, let's say requests.ts, and let's paste this in, and actually, how do we want to do this? Let's actually add a temp.ml just to paste some OCaml code, and we can paste that in there. That's fine. And we can v-split that, and we'll jump into our requests. So let's give this a type. A request is going to have let's say we have a type initialize request, and this is going to be a read-only. It'll have a name, I guess. Method name will be initialize, and then we'll have a Dune version. That'll be, maybe we need a custom type for this, and then we need a protocol version. Maybe we need a custom type for this. Okay. And then we'll give this a kind. And it'll be initialize. That'll be our discriminator in our union. So we'll say type request. Yep. Duplicate identifier request? From where? Okay, I don't know if the protocol version is actually number or not. I can't remember. But let's go look at what the version is. Jump back over here. Actually, we can do this and close this window completely. Let's close that side. A Dune version is this guy. So so we have a version.ts, and we'll paste that in there. Give that a highlight or a comment, and we'll say type version export type version equals read only, and we get a yeah, that's actually right. Right, that's major minor. And then we can say export const latest is going to be 313. And then we can also give this like, let's say we have, let's jump up and make a brand.ts, save that. And we can copy brand from Melange FFI, which we'll probably actually need Melange FFI. So maybe we just install it now. Yeah, let's do that. I think it's exported from Melange FFI. We'll find out. So let's install that. Bun install. Oh, did I already install it? Maybe we did. Import brand from Melange FFI. Sick. Sick. Yep, that's what we want. And then we'll say export. Oh, we don't need this file anymore, actually. We can delete brand. And we'll go into version and we'll say paste. Oh, you son of a bitch. Import brand from Melange FFI. We might want to like export a function called like create nominal type or something. Let me add that to a to-do list. To-do.markdown. Consider adding a nominal types export, e.g. renaming brand. All right. So in here, we have brand. So let's say, that's actually wrong. Sorry, chat. Let me work through this quick. I'm just thinking about how I want to actually do this. Realize I'm not talking much. Okay, so we're probably going to end up moving this branded stuff into Melange FFI and just export helpers to do this instead. We're using brands to effectively get nominal typing in TypeScript. And I'm kind of just playing around with patterns between exporting consts and using namespaces in TypeScript to find like an API or a developer experience that I think feels good. So, sorry, I just had to think through what I was doing there and how I wanted to copy and paste stuff. Cool. Okay. So let's go back to our, let's rotate these. Now we should be able to get in, let's import brand, and this should come from brand, /brand, right? And that should be now brand.apply. Yeah, cool. All right, I really like namespaces. I think they're great. Is this broken? Do I not have diagnostics on? I do. Is that valid? Oh my god, my cursor's going crazy. There we go. I think I could then do like type brand too. Duplicate. How do I get that? Do I have to do a second import to get the type? Is this also a type now? Am I not getting autocomplete? Wait, okay, there we go. Can I just export brand declaration or didn't I do this in Melange? How did I do this? we have a type and then we have a namespace. Like that's effectively what I want to do. So if we come back over here, maybe we just steal this type and we come back and we say, boom. We gotta go forward and grab that and we paste that in here too. We can say export type brand. Okay, so that works there. Let's vsplit this and then go to our version file again. And in here, we're going to say, this is a block, and we'll import brand from brand. Okay. Okay, that looks good. And then we'll say brand.apply. And brand.apply takes our type. So we'll say major and minor. And then we apply our actual brand, which we can say const. Yeah, we can do that.
Functions describe the world.
Okay, so what does this actually return us? We get a version. Then we can like do something like we could probably export this type. No, it can be opaque, I guess. We can do get export function, get major version. Right. Because we are choosing to ignore the inner value, so maybe we go here and we say that, and then we say T and B. Okay, that should give us access down there. Yeah. Look at that, chat. Isn't that nifty? I would like to hide that, though. which is why I was like foregoing the T there. The good thing is we can
describe the world.
if we ignore the T, right? If we come back over here and we do what we were doing before, can we use the unbrand? Infer X unknown. So what happens if we do that? Right, because we're probably because we're doing this again. Yeah. What advantages does OCaml give me over a conventional language? I would say OCaml is a conventional language. It's a general purpose programming language, but it gives you really good type safety. It gives you bulletproof type safety, actually. It gives you really amazing type inference. You get immutability by default. You get really, really good performance. You get a good story around compiling to JavaScript. You get good C interopt, and it's fun to write. So I don't think it's going to be possible to hide this type without doing casts, which I don't really want to do. Yeah, that's awesome, Big Blaster. If you run into any pain points, feel free to just ask in chat or our Discord. I wish I could just like hide this. I could use a class to do that, I guess. I don't really want to use classes though. I shouldn't be able to update this, right? Equals 4. Yeah. Okay, it's at least because you give me. Because they feel closer to OCaml's modules. I'm just kind of playing around with different ways to write TypeScript that feels closer to OCaml. So if we wanted to set, let's write the same function just for minor. M, change to V, this will be minor. That'll be changed to there. That'll be minor. And then we can say export function set. Really, we just need, I guess we don't even need those because they're on there, right? Like, that's not super important. So let's say we have this, anything you've come across that you didn't know about namespaces yet? Not particularly. I've been writing TypeScript code like this for a while. Although I wasn't using namespaces, I was doing something like, if we were to take this exact example, it would have ended up looking like export const version equals this, right? It would have looked like latest, and then we would have done like that. I don't think it's actually that different. I think it effectively does like the same thing. I don't know if there's, I don't know what the trade-offs between doing something like this are versus using a namespace yet. Like, yeah, I just don't know. Namespaces kind of feel cleaner. Here we get access to this. Yeah, I don't know. Just kind of playing around. Thank you for the follow. I am Ian Muhia. Appreciate you hanging out. All right, so we need to convert this to an S expression now. So let's go see how they did this. Let's gank that, put that down here. And they're going to say it's going to turn into a pair of an int. So what does Dune do when the pair function? We might want to write this in. These are the kind of functions we might want to write into S tier. So let's just return this as version for now. And let's jump to Dune. And we want to go to conversion. And there should be a pair in here. Okay. All right, so we have this type T here, where a pair is some A values, which is an S expression. And then we have a B of values, which is an S expression of T, K. And we get back an AB values of T. OpenConv pair int. We get a T dot a conversion.value type. So it's an A in values. So we get this com.value back. So what do we do after we have that? So if we go and look at our client, we go into create again. Boom. All right, so we don't have any sort of S expression thing yet, but we do get the Dune version, which is going to be that tuple. We have a protocol version, which is going to be, I guess, the Dune RPC protocol, and an ID coming in, which is going to be a atom. Yeah, canonical S expression. That looks good. Field required. So what's this turn into? A version T, fields of COM-T, and then we create this record. What does this actually return? What is our return type here? So let's annotate that to make ourselves less confused. So that's what that's going to return. What does 3 do? Takes an A, so there's our A, takes a T, that's our T, and then takes an F, and it throws all those into a tuple. This is very complicated. Oops. I want to Get out of my face, tail scale. That last band was Kissemity, maybe? Let me look. Or yeah, Kismet. Let me copy that. Paste that in. Yeah, no problem. So we make this. This is going to be a id.t. Okay, so what does this look like? This is the part we really care about.
Functions describe the world.
IO what? To S expression. Just returns itself. It's already an S expression. The current song is Hell in the Hallways, I think. Or no, it's The People in the Attic by Ice Nine Kills. So this is getting our request, initialize request.t. We go look at the type definition. Yeah. And then what does toCall do? Great. Thank you, LSP. That's cool, I guess. toCall, of call, toCall. So we convert, we put a method underscore on, and then we put a params object, which we convert that to an S expression. Okay. Okay. This is making a ton of sense now. So we might need to go make some updates to our S tier library, but we have this version. Yeah, let's go do some work on our S tier library. Let's quit out of here and go to S tier. What? Why was OCaml, is this not built? OPAM install? Oh, that's right, because we have that law. I believe Unknown package compiler libs. Is that true? Compiler libs. Do I need this dependency in here? I don't know where this came from. If it was me or Leo. This is from the Lexing library. Why can't I install it? It's not finding it. I'm having Dune build at install. Sure. OCaml install deps only. Yes. It's going to freak out about compiler libs. Why? ¿Por qué? Okay, so I don't need it in the Dune project. Let's go Dune project. Boom, okay. Hold on. Before we do this, so we're gonna want some sort of, we're gonna want an API to convert generic JavaScript objects into S expressions. Or maybe we just have like a 2atom and 2list, and then we can compose those. And we can build off of there. Man, my arm is super sore. Why? So let's say we go into types, and let's think about this from there first. Let's think about this from an API level.
Functions describe the world.
Let's say we want to have like a function, export function, and it's going to be like atom, right? Could do something like that, and then like export function list. And what does that actually end up looking like in our source? We have S tier. We have a list of T's, list atom of string. So what does an atom end up looking like? If you were to serialize an atom straight up, it's just like, would this count as an atom? Like, atom. That's like all it is. And then what would this look like? What would you call this structure here? That's a list with one atom. Okay. That's a list with two atoms. Interesting. Okay. If it has parens is a list. Okay. Okay. So let's then say let atom of this will be stir, and we can say let list. Yeah. Atom, list atom, list atom, list atom. Okay. That checks. So if we do that, you can rename that the list. No, let's make that list. If we go look in here then, our source, index.that, we need to add const atom, yep, and then const list. This will constructs an atom, and parameters value of the atom, and then returns. Do we want an atom type actually? Maybe that makes sense. Or do we return? Well, an atom is just an S expression, so how do we express that in our .dts? We could say export type atom is void atom, and then export type list that, and then this becomes atom or list. In fact, we could do brand atom something like that. Aren't really types, they're constructors. Right, right. So I don't think we do need that. Oh, whoops, I don't need these exports. Duh. We'll come down here and we'll add atom list types s expression. Y. So it can find that. Does JSDoc do a different syntax for arrays? That's okay. All right, so let's try building this and see what we get for the JavaScript output. Okay, and that should get us a dist, source, and index.mjs. Okay. That looks good. So why is it not seeing?
Functions describe the world.
Thank you for the follow there, Jagged.
Functions describe the world.
Oh, I must have wrote that wrong. Yeah, I did. That doesn't feel right either. Hold on here. Oh, because I'm looking at the wrong thing. Right. Let me rename this to S tier. I'm looking at the wrong freaking file. I actually don't even think I need these annotations in this file. because our annotation should actually come from our types. This guy right here. Yeah. Okay, so let's go. Right, I keep forgetting how this works. Let's yoink that. That'll come over here. Now we don't need types. Right. I am dumb. Dumb. And here we can use probably better syntax and say, okay, that looks good there. And if we v-split, we come into source. In here, we can get rid of like a lot of this shit. Okay. That looks good, chat. That looks like what we're going for. Dis source. Felt like my J key stopped working there for a second. Okay, index in here. That's good. Yeah. Yep, that looks good. That looks good. ToString. And these are going to all be controlled by the .dts file. So if we go in here, let me make sure the package JSON looks good. Points at that, perfect. So let's add, git commit, add atom, and list constructors. And then we'll say npm version patch. And we'll say that, git commit amend, right quit, git push, and npm publish. All right. So we come up here. This is version 5. So let's go back to this, close that, open our terminal. We'll say bun install. Can I just say bun update? S tier? No. Do it again. Do it again. Bun install S tier at latest. Okay, got it. Sweet. So we got S tier 5 now in our RPC server. So let's go back. So in here we should have atom. Nice. Noise. Okay, so we can construct atoms and lists now. That gives us a good foundation. Now we want to go back to looking at how Dune constructs their S expressions from this. So we should probably be able to play with this in our So we should have, what is this? Dune RPC private types. And it is the initialize request. Okay, so let's try this. So we should be able to say Dune RPC dot v1 dot. Oh, can we not get to those? Shoot. How is this exposed? Request to call. Dune RPC.v1. v1.initialize. Ah, there it is. Create. And that is a function that takes an ID and returns an initialize. But I don't think I have anything in v1 that lets me serialize that, do I? I mean, we could just add a thing here and recompile. Okay, we actually might be okay looking at this. So let's look at, we want to say, the idea is going to be, do I have an ID in scope? I do, okay. So let's say Dune RPC, let's say init rec equals Dune RPC dot v1 dot initialize dot create, and wants an ID, and that'll be ID. In fact, we can just say that. Has types specific. Sure. So let's reassign ID. Dune RPC v1 dot ID make. And what does that want? Takes a CS expression. Okay, so we can pass in our ID there, which we already borked, but that's fine. This is going to be CS expression dot atom, and it'll be test. Oh, we forgot. We got to do this. Doing the old @@. Okay, so now we have this ID, which is a RPC ID v1. So we can jump back up to the request and do that. Okay, we have our request, this abstract type, and we want to say Dune RPC.v1. This is going to tell us a lot of information here, chat. Initialize dot request. Oh, I can't get to the request, you son of a bitch. I just want that frickin' to call. Well, this seems like it should be public, right? It's in private. This thing right here. Frick. Let's make sure the RPC server actually broadcasts what we want before we go further down this rabbit hole. That'd be really bad if it didn't. Tune RPC. So we ping the server. We send the request to the server. Got a response from the server, creating progress stream. Sub progress. Progress of friends. Man, I wish this had like way better I wish this had way better docs because this is so hard to tell what's happening. I am using NeoVim off 9. Yeah, no problem. You can find my dot files here too. They're pretty well commented, and I'm happy to help if you have any questions. All right, let's keep exploring this a little bit. So what is a user message? User message content is composed of an optional file location and a list of paragraphs. The various paragraphs will be printed one after the other and will all start at the beginning of the line. They are all wrapped inside a PP box. Okay. This is very difficult to follow. But we're going to get it. We're going to do it, chat. Swear it. So let's see if we can at least ping the server. Okay. So we know we have this like atom here. So let's start there. We have v1 id.make, and this one's a ID. So I guess let's make an ID. What do we have in requests? To version. And then we want, I have some stuff in here, id.t. Yeah, we probably want an id.ts. So in here, let's do something similar that we did to version. And this is going to be ID. Right now, our brand can be that. I think my J key's starting to get a little wonky. Might have to take it off. Yeah, it feels all right. So that'll be void. And then we'll say, I wonder if I can come down in here, this dot latest.
Functions describe the world.
No, it'd be okay. And then when we make an ID, what does this do under the covers? ID is already an S expression. Is that true? It is. So it takes a S expression. So let's say export function make, and it's going to take, did I have a better name on there? Just call it ID, I guess. Take an ID, which is a canonical S expression. And we're going to return a ID. And then we say return brand.apply, and it'll be ID and brand. Yeah, look at that, chat. So then, we want to go to, let's close like all of these. And we want to go to the RPC example, this one, U. So we have our ID, and we call create on initialize. Let's see where that goes. in here, we get an ID, and then we make an initialize request. Okay, so we were doing that before. And that's our... I'm surprised that's not an id.t. I mean, I guess they are really actually aliases. So it's fine. Like, is that going to tell me it's a... Yeah, okay. Yeah, that says it's just an alias. Okay, so we jump back and we rotate our windows here. Down here we get... We're going to go to request. And we have this thing here. So now we have this as a version, right? We need to import that. And we don't have a protocol version yet. Which, if we go look at protocol version, it's just going to be... Okay, so let's copy that and go back to here, and we'll say protocol version .ts. Write that, jump in here, paste that, and we'll do what we did for version, basically. Copy that, view in Word, paste over that, paste over that. You can delete this. You can import brand. And this is going to take... Okay. Now back in our requests, we can come in here, and this will be protocol version. Okay. All right, so we want to construct one of these guys. So how do we want to set this module up? So maybe we come in here and we do something like the same way we've been doing this, and we say export namespace. And it'll be initialize request. My autocomplete died for some reason. So then in here we'll say export function make, and this is going to take, it's just going to take an ID, which will be a ID, and it will return an initialize request. Did we make an ID file? We did. These are all exported. Why can't I import this type? There it is. Weird. TypeScript just got confused. So this will also have an ID on it. What up, Nate? Happy Saturday, man. Hope you got some sleep overnight and today. Hopefully we're up all night with the baby. Some of these I actually don't think we need a brand. Not sure if these brands are buying us anything. Other than it ensures it comes from our API, which is kind of useful. FML, val in, and int val, very, very different things. Int val of x extracts the integer value of x. Val underscore int constructs an OCaml box integer value from x. Store field record field n val will take both happily. One of them will fuck the GC. That sounds lovely. We get you, and we can get rid of this kind, and here we can put initialize request. Okay, that looks a little bit better. So when we make, we'll return brand.apply. We'll actually say like const base request is this guy. And it'll have method name, initialize. It'll have Dune version, be version.latest, and then we'll have protocol version.latest. Yep. And then we'll say brand.apply, and we'll say base request and ID, and then we'll give it our initialize request. What are we missing here? A comma? Or are we missing a comma? We're missing that. Method name, initialize ID, protocol version, the latest. All right, what are you upset about? Oh, right. Let's do this. And we'll come up here and we'll say initialize request brand. Initialize request brand, and that will be, paste that in, right, that'll be type of, and then down here we get this, and we change around that, and it'll be initialize request brand. And this still isn't happy. What are we doing wrong? Ah, I see what we did wrong here. I got it. This needs to be brand.apply. In fact, we can just use make, right? Version make 313. Need to do the same thing in protocol version. This will be protocol version.make0. There we go. Are we happy now? Still not happy. Where are the errors? Duplicate identifier? Sure. Next error. All right. No more diagnostics. Nice. So we now can make a request, right? We've got this lovely little make function, which is going to return us this type here. And the outside world can't use it without using our library. So we have this initialize request. We get one of those. And once we get that, where do we go from there? We get this init, we build this where thing. So let's close this over here for now. Do a vsplit on this. And actually, let's harpoon this. That'll make navigating back to this way easier. So our where just points at our Dune file, or our Dune RPC file. Yeah. And then we say connect chan. This returns our little file descriptor things. And then we give it the chan, we give it our init. And inside our init, we say connect with menu. then connect raw. Let's not care about that. That doesn't do anything with the stuff we already have. That takes our initialize request. Let's go to create. So we create this structure. That's our client. That's what a client looks like. Okay. Then we have this run function, which makes a we convert the request to a call. Okay, we do need that. So we create another ID. We convert our request to a call. So that's the next thing we need to do. Sure. To call. So we're going to have this structure here where it's a method and params. And params is going to be a CS expression. So let's go make that type now. Slowly but surely, we are reverse engineering this. So a call, do that, and we'll come in here and we're gonna have, let's copy this, over there, paste that, come over here, yoink that, control 1. So this will be, our brand will be a call, and then this will be call, and our actual structure will be a read only, boom, boom, and you're gonna get a method, which will be some string. And then we'll have params, which is a canonical S expression. And then down here, this will be call. And to create a call, we will take a method string and a params, which is a canonical S expression, and we're going to return a call. And in here, this is going to be a method and params. That should be happy. Yeah. So now we can close this, split this, and go to, we want to convert our initialize request to call. So we'll say export function to call, and this is going to take a request. It's going to do something like that. So our request is not a canonical S expression, so we have to convert the rest of this into an S expression. So that's where this is going to start getting annoying and tricky, but I think we'll be okay. So I think for each of our existing types, we're going to want to convert it into S expressions, like atoms and stuff, which we already wrote in S tier the ability to do. takes a T. What are we in right now? A request. So I think we can write a simple version of this. It doesn't look like it's doing anything fancy here other than like two stringing things and putting them in an atom or a list. So, given that's true, I think dot make right. So let's just say as canonical S expression for now, as any as yeah. So we want to say this needs a 2S expression function 2S expression to canonical. Actually, let's say 2S expression, and then we'll also have a second function. We can just throw in here, throw new error not implemented, and then we'll have a function called export to canonical S expression, which is going to be, this will take a request. 1 second, chat. Hello? Oh yeah? Did he do well? Nice. No. I'm excited to see him.
Functions describe the world.
Well, tell me about it. Well, actually, tell me about it when you get home. I'm streaming at the moment, so I will. Oh. All right. Well, you can explain to chat what you and Bodhi did when you get home. Okie dokie. Bye. All right, chat. 1 second. I am going to run a 1-minute ad break so people don't get slammed with them, and I'm going to run to the bathroom quick. I will be right back, y'all. Okay. Okay, we're back. Let's say we can say to canonical S expression, export function, and this will take the same thing. We can just copy and paste that, and this will be to canonical. And in here, we'll say how do we want to do this? We need a way to construct S expressions, right? Because like we can go into each of our little tiny things, like our Dune version. We can go into our version and we can say we need to convert it into an S expression. So if we turn it to S expression, this will be a S expression from there. We can just S tier of, ooh. I do like that, Leo. That's nice. So if we did that, that would look like, where's our types? We can go into here and we could say atom list. We could say export function of, and this is going to take an array of, just an array of any, really, right? Any should capture that. And this will return an S expression. Yeah. So we go to implement that. We're going to want to do that in, let's rotate. And we'll have to do that in U. So let's write our function. We'll say function of, and we'll get our value, which will be, we'll have to annotate this. At prim, it's not quite right, but this will be any array value, and it's going to return a I don't really need to do that here, but whatever. Did that just nail that? So if it's an array, well, it will always be an array, right? So this check would be more like, no, let's just write this ourselves. It's close, but it's not quite right, right? It's like, if array dot is array and value dot length is greater than 1. Declaration. Oh, I see. So if it's an array and value.length is greater than 1, we pass it to list. We map over each value we say of. I think that might be pretty damn close to correct. Otherwise, it's an atom. Okay, let's try publishing this and we'll play around with it. Maybe not even check the length. Well, wouldn't that just fall through to our else statement, right? So value of I guess we don't need the length check. I think you're right, actually. We can play with this quick. Let's do a build. All right, let's do a Dune build. So that will get us a build directory, or a dist directory. And we go look at index. This looks good. So let's create a test in here. Test let's just say TS. What? What? And we go in here and we can say web file. We'll import of from /index. Nice, we broke TS server, everyone. Talking about you can't find. It's right there. And then we can say like const sexp equals of foobar baz, and let's actually change to there. We'll put another one in and we'll say bar and baz. And let's say we have just like a number and maybe like a true false. And then we can say console.log. We can say serialize that. We're going to need to bring that in. Okay, and we should be able to go into dist source, and we can run bund test. Womp womp. That is okay, chat. We can debug this probably pretty easy. Let's go ahead and console.log that. And GC that. So we got this big, ugly structure. Let's keep it simple. Actually, let's start over and go simple rather than going all in here. Let's close this, and then we'll close this, and we'll do the old vertical split here. Is that what we would expect? So tag 1 is going to be list. Tag 2 is foo. smells new drugs from the 80s. Okay. Well, that's good to know that we are already bombing. So let's try bringing in Atom and change a word. Oh. I think I know the problem. This should probably be deserialized. Whoops. I probably just nuked this. That feels like it just no-opted. That actually never ended. It's running. So that's telling me there's likely a bug in deserialize. S tier of string. Right. That would be like, I love this song. Okay, that looks good. And now what happens if we do serialize? This song is gonna be All Over You by the Spill Canvas. This 100% isn't doing what I thought it was doing. Sorry. Justine just got home and the garage door went up, so it's the apocalypse for them. Yeah, so we're not having the results I would have expected. So if I were to say of string, I should be able to pass it like, let's go back to our test. Let's start super simple. And let's actually import star from S tier, star as S tier from, yeah. And let's actually do this. And then we can say console.log tweet that. We can say s underscore tier dot of string, and we should be able to say something like foo bar. Oh my goodness. So Bodhi went to a child's, what?
It's the Children's Museum in Raleigh. It's like I think a science museum. I don't know. It's called Marbles. Super cute. And we partnered with NC State's veterinary school. There's I think it's called Voice, which is like one of the inclusive clubs on campus. And they hosted a See a Vet, Be a Vet event. And they had therapy dogs come so kids could practice using a stethoscope on them. It was so cute.
Show them the pictures.
Oh my gosh, okay. Is that a good one to show?
Yeah.
Wait, I don't know how to do this. I'm trying to like...
You can have a frame of reference down there.
Okay, great. So Bodhi wears a bow tie whenever we do therapy events because that's his work attire. So he knows he's working if he wears that.
That is not a pug.
Who just asked if it was a pug?
Leo did. It's a golden retriever.
This isn't the best, but look at that.
Oh, did you show that one?
Not yet. This is Bodhi and Ollie. Ollie is also a golden retriever, and he was rescued from the same rescue as Bodhi was. But he's a sweet old man. And then we took a picture outside too, because you can see the Marbles IMAX.
Oh.
Okay, this is the last one. It's so cute though.
So our toString
Okay, bye.
doesn't work, which is a problem. I don't know why our toString, so the IPL is what you had originally wrote. I'm guessing it's getting lost. It's messing up in the translation process. So if we go to toString, it's going to take a T, which would be an S expression. We're calling this function standard format. We call S expression PP, and we're saying if the t.tag is an atom, we're calling print, no padding and format. Maybe I just throw a debugger in here and we run it in inspect mode. It's probably the easiest way, I bet. Badcot taught me how to do this. So how the fuck do I do this?
Where's your grill cover?
Is it not in the yard anywhere?
No.
Fuck. All right. We'll look for it then. Probably blew away.
Probably.
It's probably down in the woods if I had to guess. Let's see here. I have to remember how to do this. Chrome, no debugger. Yeah, we're just gonna run it with that. I wonder if we can do bun inspect. I hope so. Probably not. Does bun have a bun inspect? Yeah, here we go. Oh, sick. This makes it even easier. Let's go bun. So I should be able to just come over here and like in our test, and we can probably just say debugger. I hardly know her. Let's actually make say const s expression equals that, and then we'll pass in s expression. We can throw that debugger there, and let's say conster and then here we can just say stir. Okay, so now we theoretically should be able to come over here and say bun test dash dash inspect. Just kidding. Bun dash dash inspect test.ts. It just ends immediately. Debug bun.sh. Okay. How do I do this? This isn't making sense to me. I mean, maybe we just, do I have to trick it into doing something like set timeout, and we'll give it like 10 seconds. And then in here, we'll grab all of this. So it gives us an opportunity to at least, what is this? Why is my freaking LSP so borked? What the hell is happening? Why can't I format? This is so annoying. All right, we gotta go grab that quick. Yoink that, throw that in there. Hit, let's go. Professional debugging over here, chat. I can't make this any bigger either, unfortunately. So bear with me. So our S expression is this object. This looks like the correct representation, right? Tag 0 translates to an atom. and tag 1 is a list. So we have a list that has 2 atoms in it. That seems correct. That's what we would expect. Okay. Let's step into this function. And in here we have a T, the same guy. Yep. Same object. So now let's step into what is K in this scope? Stir comes back empty. All right, so we need more logs in there. So let's go back over here and go to toString, and let's put another debugger in the pretty printer. And let's put a debugger right there. And we can come over here and make that full screen. Do the same deal, inspect test. Yoink. Yoink. Oh, it already ended. Damn it. Damn it. I am going too slow. Let's just close that. We'll get a new tab and we'll do it again. Seemed like kind of weird. All right, there we hit and we can play. That'll drop us to that debugger. Okay, so we get here and I wish I could make this font bigger. Just doesn't want to do anything. So if t.tag, that's not going to be the fact or the case here. Wait, why is t.tag? How did we get an extra 0, right? We have an extra tag. When did that happen? Call stack. Where did this outer tag? So the outer tag is an atom. Tag 0 is an atom, right? I'm not crazy. If we go up to S tier and we say we're going to make an atom. Yeah, atoms are 0. The outside should always be 1. So when we say of string, it's the OK wrapper. You're right.
I'm running to Target with Emily.
What?
I'm running to Target with Emily.
Okay. It does. It does. If we were doing this in a better test harness. Okay. Right. I actually have a project set up for this. It's because we don't have types right now because we're inside the library. Good look, Leo, as usual. Let's open this one. Where is it? I have a testing somewhere. It's in temp. Change to FFI test. I think this is it. Package JSON. We get S tier latest. And let's grab also melange FFI at latest. Hell yeah, it's a Thocky keyboard. You can wager 1,000 points to try to win one. Imagine if I just won my own game there. That would be so bad. I get so scared that that's going to happen sometime. Right, I was already testing here, so... yeah, so now we have our actual frickin' types. So S tier dot... I don't know why I didn't get of. Oh, it's because I never published it? Right. But we should be able to test here. Yeah. All right, so let's publish a version of S tier because I feel pretty good about what we have actually. So let's quit out of here and check our status. And we'll say add of. And then we'll say npm version patch, add again, git commit dash amend. Right quit, git push, npm publish. Okay, that just got published. We can jump back over to here and let's call this testing. Let's do a bun I. Bun update S tier. Sweet. So now we should have S tier of, right? So S tier dot of, there it is. Look at that. Pretty nifty. Oh, we could link actually. Good look. But let's try atom and then value. And we'll say const s expression. And then we want to say we want to do s tier dot serialize and s expression. All right, now let's try running this. Bun index.ts. Boom. Blew up. Ha. Undefined is not an object evaluating t.tag. So now this is probably where we're going to want to throw our good old Vim dis, I think I deleted the test, yeah. So let's go here and we'll do our set timeout. And we'll do 1000 times 10. And here we'll grab all this. Yoink. Paste. Format. Good. We don't really need this other stuff for now. What up, Roasted? Got some Taylor Swift. Oh, shit. Oh, right. Because we can get rid of that stuff. Grab that quick. Yoink. All right. So we hit here. I mean, that looks right? We have a list. Inside the list, we have an atom and a second atom. That looks good. So if we step over, what's this say now? Standard lib format for format, okay. And then it takes an object, char literal. So it's gonna return, okay, that makes sense. Format.param. Anything. What up, Trash Puppy? What up, Cop? We are just debugging some lovely JavaScript that was generated from OCaml. This is not MV Chad. This is my own NeoVim config. All right, well, then we can go try to clean that up. I'm still a little, it looks like our of function worked correctly though. That looked like it gave us a good result there. Just to check one more time to make sure I don't have to go fix that quick. Yeah, it looks like of worked well. All right, let's go mess around with the printer. So if we go look in here, so if we have an atom, we just return the string. And if we have parts, we call, we'll say boom, pretty print list format. Do I have a runaway LSP somewhere? Doesn't look like it. Frickin' OCaml. Yeah, okay. Let's try that, and we're gonna go and we'll say, all right, so we have a build error in stier.ml. So let's go look at that. And here, I guess we can change this to toString. Just to keep it consistent. Okay. All right, now let's do the link approach so we don't have to publish it. Let's quit out of there and say npm link. Is it bunlink? Bunlink stier.
Functions describe the world.
We can go over to 5. Thank you for the follow. Appreciate it. And in our package JSON here, we can say view in Word, paste that in, and let's click out of that. And we can remove node modules in the lock and bun install. All right, so now we're linked to stier, which is good. Let's just see if we get lucky and go into our index and yoink that, paste that up there. Can copy all that. Oh, love of Christ. Why can I not see that? There's the types. There's of. Is TypeScript just confused? Property does not import types index. Why? Whatever. So we're getting the same error. T.tag does not. Somehow we have undefined going into toString at 3247, 3246. So let's go ahead and jump back into the debugger here. Okay. Bun inspect. Yoink that, throw that there, do that, hit the old refresh. Boom. Okay. We step over, we get our S expression. We have a list, an atom, and an atom. Okay. And now let's step into this function. ToString, t.tag does not equal 0. So let's step over that check. So we're losing it somewhere down inside this concat function or this ToString. My font's not actually dank mono anymore. I need to update that. My font, I just switched it again this morning, is Mona Lisa font. That's my font. So let's go back to S tier. We should be able to edit this now and still get our like breakpoints. So in dist source S tier, we call this. Do we call that? No, we don't. We call ToString, right? Serialize ToString goes to here. So we should be able to throw a debugger here. And let's say let's also throw a debugger here. And let's just make sure bun link. And let's go back over to 5, bump that over here and that. Uninstall. And go over here. We can just close that, open a new tab, go ahead and run the old bun dash dash, grab our link, yoink, throw it in here. Okay. We get our S expression, list of 2 atoms, _0 is the array. If we click play, we should hit another debugger. Yeah, that's good. So this is the top level. So this is going to be our list. We should be able to click play again, hit here again. Okay, this should be the first. Or no. Right. t dot 0 is an array of tags. Yeah. So if we press play again, we end up here, and t is undefined. How did we end up here as undefined? What? Let's go back up the stack. So here we're still good. Function's going to be our toString. Okay, we have params, and then let's see here, match. So A1, it's looking for head and tail. And it's just variance. Right, I did something wrong in how we implemented our I think I have an idea of what I did wrong here. I know what I did. So OCaml doesn't operate on arrays, it operates on linked lists. Okay, so we're going to do some recursion. And we'll let const list equals list.ofArray. And then we'll return of list. I think that's what we needed to do, chat. In fact, we can even skip this part. Go ahead and throw that in there instead of a typo. So that is going to be, this is going to look like value, yeah. Does melange have a is list? So we know that it's going to be a list, right? Because we converted it up front. Or we enforce that it's a list coming in rather than an array. And then our life just gets so much easier. What does our type say? So we are using already melange FFI stuff. Okay. We're going to come in here, and this is going to be where's of? This will be change around that. That'll be list any. Yeah. Is that what we want? So let's assume we're getting a list coming in. We're going to want to fold on it, right? Rather than, we're going to want to fold on it rather than mapping on it. Or what are we going to want to do? Turn it into an atom. No, we map. It's fine. That's fine. So we should be able to say, now this is a list coming in. We should be able to say list.map, and we'll get our, what is the signature on this? It takes a function. So this will be x, and then we'll say in here, we'll no op, and then we'll say value. We'll say val. And that should be an any, yeah. And in here, it could be a list. we need a isList function. So if we do a mem full concat append cons is empty length init. Let's go to the init function here. So it's just going to have head and tail on it. Yeah, so let's go up again into our types and let's add to list is list. Yeah. And our value, if value.head equals undefined or value.tail equals undefined, well, we can just return that. Well, const has, there's probably a better way, has head equals, let's go make sure again. Whoops, wrong file, list. Will it always have a head and tail? It will. And it will use an empty value. Yeah, okay, they'll always have a head and a tail. And it will never be undefined. So we can use that initial check we were just doing. That was safe. Okay, so let's go update our DTS. Do we do any casts in here? No. It's literally right there. Oh, it's because I'm still in the comment. Dumb. So now we can go link this to, so let's go back to here. We can say, bun link, and we'll grab this. Yoink. Whoops. Go back to 5, go to our package JSON, view in Word, change word link, and it'll be melange FFI, and let's delete out of there, remove all that shit, bun install. Okay, everything's linked up. Oh, we didn't want to link there. We wanted to link over here. So let's go to this package JSON and say this is going to be link. I don't even know if I bun installed or what I did in here. So now we have this list thing, right? We can check whether a value is a list. What was our last original implementation of this thing? So we want to do something similar. That looks better, right? I think we still have our, this would be any. Yeah, we want an internal, I mean, that might be fine. Let's go look at our dist, source, index. This is the generated file. All right, let's see what happens here. You go to this, and we can probably npm or bun install again. Okay, and we can go to our index. Now in here, we can run this again and hopefully get our inspector. Yoink that, go throw that up here. Hit our debugger. No? Oh, we didn't throw our debugger in? Dumb. Yoink. All right, we hit our debugger. Let's look at our S expression now. Oh, dude, it didn't like that of at all. Yikes. O is not a function. All right, we'll have to step into that and see what we did. So let's step over, step into. So right now we have value. List is list. Oh, because it's not a freaking list. I'm an idiot. List dot from array, or it's of array. What you want? To array, of array. Yeah, okay. Let that go. It's going to bomb out. Getting closer, chat. Getting closer. All right. So step over. We still bombed out. Can't find variable list. Right, because we didn't import it. I wish I was getting my types accurately in here. It's kind of annoying. What you want? Okay, we got our list. Here we go. So our head is an atom. Our tail is a value. That looks pretty good. Are we feeling lucky? Look at that. I'm still not sure that's exactly what we want, but we're getting closer. We at least didn't break stuff. And we confirmed that our of function will work. Let's see what happens if we do a nested array, though. I'm actually curious. I mean, this should be smart enough because it launch, yeah, it'll convert it to a list under the covers. Shouldn't serialize pretty print the list, though? Or is it deserialize? So this is going to give us an S expression. No, we deserialize a string to that. We serialize this to a string. This doesn't seem like it worked, actually. Right? I'm not crazy. What happens if we uncomment the rest of these? And we can get rid of the timeout now. We don't need to debug. Yeah, I would expect that too. So let's see what happens here. Let's go bun index.ts. Kind of right. We need. So our of implementation still isn't correct. I wonder if this breaks if we give it a list. Oh, that still worked. Because I would expect these things to be the same, right? Like these result and S expression should be equivalent. Okay, so that's interesting. The top one's the correct one. The bottom one's wrong. So we're not quite correct yet. So our implementation of is wrong. Which it doesn't seem like it should be. I guess we need to throw a debugger here and just step through it. Yoink that, throw that over here, bada bing, bada boom, hit the old refresh, hit the debugger. All right, we should be able to click play and end up in here. Yep, so our value, yeah, those are the strings, that makes sense. Can we say list dot is list, and we should be able to say value, and this should say true. False? What? It has a head and a tail. Did I screw up my is list implementation? No shot, right? If I have it backwards. Classic. And this should be an and. Classic Boolean logic mishap. Okay, so we're still upset. Let's figure out again what's going on here. So let's go here, say 1,000. 10,000, that'll be 10 seconds. That'll give us more than enough time to go ahead and run bun dash dash, grab that, yoink. Right there, enter refresh. Okay, we hit. Now we should be able to say list.isList of value. That should return true. Cool. That looks good. So now let's press play. How did we not end up back in? Where did it bomb? Do I have my... function index? I have the arguments backwards. Thought I took care of this. The things I do to make this feel more like JavaScript. Okay, so we should be able to go to here now and close the quick fix list, clear that, do a bun install. Should get the updates from Melange. And now, how do we get in here? It's not what I wanted. Okay, so now that we get in here, we want to run, let's just see if we get an error. Okay. Did not do what I expected it to. Okay. Step over. Step over. I mean, sure, that works too. So let's just try playing down here in the console, right? So we have list.map, and that's going to take a function that takes a val and an index. And let's just return the index. And then we'll give it value. f.apply is not a function. Okay, let's just say list dot map or list dot is list. Let's make sure this is still working. True. Okay. How do we debug this? I see the problem. At least part of the problem. We have our arguments backwards in S tier. Map is actually data last instead of data first, right? Yeah. Yeah. The entire API is data last. So let's jump to S tier. This will be of and value. And we can come over to testing, go back over here, go ahead and do a Doom build. And then, right, we need to fix that in here. This will be of and value. And do that. Go to 5, drop down here. Go ahead and, what up, Noons? What up, Dota? We are in deep right now, debugging shit. Wait, where do I have a typo? I don't have a typo. Get out of here. I'm starting to get a little burnt out, a little tired here, so I might take a break and go eat some food and run some errands. But I want to keep going a little bit. And yoink that. Throw that down here. Okay, so let's assign that to a variable. So let's say L equals that. Var L equals that. So now we have L. Are we serious? Come on, bun. So that looks good. I want to step into this. We should be able to go over that. And we get a list back. Yep. We're going to return. Step into. So now we have value. So I should be able to say list.isList on value. True. Great. And then I should be able to say list.map. And let's just say we get our value and our index. And we go index, comma, value. Let's just say val, or we can do underscore even. Undefined is not an object evaluating o.length. Right. Right. I think I might understand what's happening. Is that our problem? Yeah, that would make sense why that was breaking. Because we were calling it with undefined. Yep, that was definitely a problem. So, given that, let's rebuild this. Instead of doing build. And let's make sure we were editing the right file. Source index, yeah. So if we go look at our build, we should see that in there now. I'm going to need to refactor this whole project to TypeScript so I get types, because this is not stellar. I can't believe we used to write JavaScript like this without types. Unbelievable. Yeah, there we go. Okay. So we built, that's the build. Let's go ahead and say that we need to we've rebuilt. Let's go to our testing. We can kill that process. Let's remove our lock file and our node modules, but install, get the latest build. Bada bing, bada boom. And let's try running this again. Let's grab the URL, yoink, throw that in there, boom, refresh. We hit, excellent. Ah, we still bombed. Okay, well, let's try again. Okay, yoink. I'll catch up on the chat here in just a quick second. Noons, I saw you had said some stuff. We'll step over, we'll step into, we'll step over. Yeah, we'll get our list, blah, blah, blah. So now we have our list built up. We'll return out, we'll step into. All right, great. So our value is going to be this list. So we should step into our of function. And now we have value as this. So we should be able to say list dot is list on value. We should get true. Great. Let's step over that. Now let's step into this. Maybe this function that takes a value and an index, but we got to flip it. Oh. That bombed on the flip. Didn't it? Am I misunderstanding how to use the flip function? It should return a new function. What up, Liquid? Happy Saturday. Okay. Dota said I learned how awful garbage collection is. Yeah, it can be pretty bad depending on your situation. Are both your dogs named Aaron? Oh, but Tis. Just want to say it's been a joy to do the PR in Create Melange app. It is on my to-do list tonight to review your PR and test it. So hopefully we get that in. Cool. Okay, that's all the chat. Why is our flippity flip not working? Oh, flip does something different than I thought. Fun XY. So we would instead say something like, How does that work? Hold on a second. That doesn't seem right. Let add x, y equals x plus y. And then we say let flipped equals fun.flip add. Standard lib, launch the fun.js. So it creates a wrapper. Okay, so that's what we need to do. We say function, flipped function, is going to be value and then index, and then we'll say boom. And then we say melange.winnie. Wait, hold on here. Let's call it now. Let val equal, damn it. Let z equals flipped 1, 2. So I don't even need this. I don't even need what this is doing here. I can do this myself. It'll be function shit. Value index, and it needs to go index value. And then we say value index. I think that's what we want. And then we can go to our testing, and down here that, and we say remove -rf, no modules in bun lock, and then we say bun I, get all our stuff, and we do this, grab this, throw that in there, boom. Hit the debugger. Hopefully. Yeah, we do. Great. Step into. We build up our linked list. Great. Step back into. Great. Step into. That should be fine. Step into. Can we step into here? Here we go. This is the stuff we're talking about, chat. This is the code we wanted to get into. Sorry, this is so tiny I can't do anything about it. For whatever reason, this interface does not let me like increase the font size. Yes, it does. That did not work at all. For real. Maybe if I open it in like Safari, since it's using JS Core. We'll try it next time around because it doesn't want to hit. All right, let's close that side window. So let's see here. Our function takes an index and a value. Our value is our list. So let's step over. Where are my controls to step? Of course I put them over there. Stupid. Step, step. What does match? Match equals value. Okay. Okay. If match, yeah. That looks pretty good, chat. That looked pretty good. That looked closer to what we want. So let's get rid of our debugger. Let's bump this down to just a millisecond. And let's print this now. We don't need it. Well, we can keep the debugger. It doesn't matter. We're not going to connect. Whoops. All right, so are these equal now? These look equal now, right? One of the dogs is behind me excited. Are you excited, Belka? Are you excited? You come to celebrate properly porting OCaml to JavaScript. Okay. Yeah. Let's I definitely think I want to be able to pretty print these variants. Like, I get that melange into the cover does this for optimization, right? Like, totally makes sense. We'll see. I don't know if I can bake that. We should be able to bake that into melange FFI, but let's go ahead and go back to our code, and now we can delete these, yoink these up into there, uncomment them. So we should get two equivalent logs on these two lines, and let's do a canonical print of the of. And let's go ahead and just run bun. Leo, I don't know if you're still here, but our of API works. Let's go a little bit more complicated. Let's go give it like a 1, and then we'll nest like a true and like a foo. Aha. So I think it assumes all of these are strings. So let's just answer in word, test if that's true, which would make sense, right? Because like in the OCaml world, we have to have the same data types in our array. So it makes sense that we would have to give everything as strings. Okay, so that's still not happy. What should this actually end up as? That S expression should be raw string equals, it's going to be atom guys, enough. There's Reverie. It hasn't been worked on in a bit. So would this end up looking like is this what this S expression should come to here? Okay, that's what I had. So let's try ignoring that and then taking this raw string and deserializing it. Okay, that worked. That's promising that we at least parsed correctly. What did we do wrong in our S expression? So we didn't do something. Our of function's still broken.
Buddy.
It looks like we didn't completely turn that into a list. Thank you for the raid, Rida Streaming. Appreciate you. How was your stream? So it looks like Melange might not do nested arrays. So we might have to go update our Melange of array implementation. What up, Redis? Yeah, we don't. I think we need to do that. Treat me decently well. We're trying to make it so it treats everyone else even better. Yeah. Because we need to enforce that a list can only ever have one type. Where are you confused at, Noons? We are writing this S-tier library. S-tier is a library that serializes and deserializes S expressions and canonical S expressions. And we need to do that because the real goal is to build a Dune RPC client in TypeScript. And the communication format that the Dune RPC server talks in is S expressions rather than like JSON. So our TypeScript client needs to know how to parse and serialize S expressions. There was no good existing S expression library in the NPM ecosystem. So what we did is we took two of the really popular ones in the OCaml ecosystem. We compiled them to JavaScript and then wrote our own wrapper around them. And that's kind of where we're at right now. So we are writing S tier in support of writing our Dune RPC client, which our Dune RPC client is going to help power our Vite plugin and our Webpack plugin. Because the way our Vite and Webpack plugins work now is we concurrently start Webpack and Vite in watch mode at the same time as we start Dune in watch mode. And rather, what we're going to do is we're going to have Vite listen to Dune's RPC server, and rather than pulling against the log file and parsing it with regex, we're just going to get updates straight from Dune across the RPC. Yeah. Hopefully that helped a little bit. All right, so one last try here. We're going to build S tier. Let's go ahead and Dune build. And then we will jump over to our testing. We'll update our dependencies. We'll bun install. And we will... This should work better now. No, it won't, because of array doesn't recursively. In fact, I would be willing to bet so the type right now would be like list.ofArray. God, got something in my eye. So let's see what happens now. That looks better. So now the question is, in Melange FFI, do we... I want to prevent TypeScript from unioning types together. I don't know how to do that. So like the option is we figure out at the type level how to prevent TypeScript from unioning shit together, or we, in our of array, we recursively just like convert any child arrays to lists. What would you guys expect? Would you expect this function right here, if you passed this argument, let's just say 1, 2, 3, 4, 5. If you pass that as an argument to of array, I'm afraid that TypeScript is going to infer t to be something like type t equals number or array. Well, actually, let's go to the TypeScript playground and actually see what TypeScript infers that to be. Maybe we'll be okay and we'll get a type error. Let's say const r is this. Let me go grab that, paste that in, and then as const, and we'll say type x equals type of r. And what's that give us? Maybe we don't say as const. Yeah, that's kind of what I was afraid of. Does anyone know if there's a way? Well, hold on. Okay. Is there any way we can enforce at the type level? We like tell TypeScript to not infer Something like that. How do we do this? Anyone know how to write this in TypeScript? All right, ChatGPT. Is that literally not the same exact type that I just gave? I think that's literally isomorphic with what we have. Okay, we can try that. That infers as never. Well, it's structural. So maybe we can do that. No. I'm just trying to infer. What am I trying to infer? I'm trying to infer the type of the first element in an array, I think is what I want to do. Infer the type, write a TypeScript type to infer the type of the first element in an array. The problem is when we call of array, Leo, it doesn't recursively convert child arrays to lists. So we were having a problem where when we had those nested lists, it was like keeping them as actual JavaScript arrays under the covers rather than like deeply converting them to linked lists. So I want to throw a type error. I want to give a type error to consumers of Melange FFI that when they pass an array into of array, every single type of the array must be the same. And we're just going to naively say like the type of this array is going to be equal to whatever the first element is. T extends any first. That's like the exact type I wrote. it would mean what would it mean? Yeah, you're right. That would mean that. So maybe the type's like, it would be the value, the type of the first, it'd be a union. It'd be the type of the first element or a list of type of the first element. Right? Let's see if ChatGPT actually did this right. I don't have a lot of faith. It's like the exact type I wrote. It's still inferring to never. All right, let's just like start simpler and we'll work our way up. Let's start with this guy. Let's see if it can infer at least number. Still does not. Okay, they have a last array element. What's up, Mohid? How do I use this? Type of weekdays, array values. Seems right. Okay.
Have you seen Mean Girls?
What?
Have you seen Mean Girls?
No.
Like the original?
Oh
You
yeah,
never
yeah.
oh.
No, I have seen the original Mean Girls. Sorry.
Okay, now look. She doesn't even go here.
Nice. Show chat. Say the line.
She doesn't even go here.
Nailed it.
Thank you.
All right, this cannot be that hard. Why is this so hard?
I'm guessing you haven't gone to the grocery store?
No, not yet.
Yikes.
I'm just gonna eat pizza.
Hey, that's what I'm gonna eat. Okay, but we have to make the pork tomorrow.
Yeah.
Okay.
Elements.
Are you going to the grocery store tomorrow?
I don't know. Might go in the morning.
Do you want to go after yoga?
Tomorrow morning?
Yeah.
Yeah, let's do that.
I'll drive that. Emily's gonna ride with us. She's also going to yoga.
Okay.
Okay.
It might be over. All right, let's just work our way up here. Type y equals this, and we'll say type of R1. Okay, we get a number array. Okay. Is that really all it took? Okay, not quite. Number or number. Man, I was about to get so mad if that would have worked. It was 1, 2. String your number. I would expect all of these to give me never right now. Never, never, and never.
Okay, now I'm leaving again.
Okay, goodbye.
I think your chat has seen me in 3 outfit changes today. Kiss your noggin and leave to go do different things.
Can you do something like array T or we might be able to actually. Let's try.
Before I forget, that's your mail.
Oh shit, we got the of raid from Alt F4. What up, BG? Everyone should go give BG a follow. What up, gang? Ah, good look. Yeah. We are fighting some TypeScript right now to make Melange better. Constrained. Okay. So that should still bomb, but it doesn't. We still need a way to like infer. Bro, I basically broke my viewers with trying to do some Nick stuff, but it was a good stream. Hell yeah. Oh, that's sick. You could just run your NeoVim from anywhere. I like that idea. We're trying to infer the first type of an array. So if we have any TypeScript gurus in here, I would love to know how I could infer the type of the first element of an array. Because like if we did this, this is gonna obviously give us, we could annotate it, and then we're like, yo dog, this lovely error message ain't it. We need it to infer the element, we still need the first element somehow. It's like we need it to be like something like this. Never. It should be, right? So const R3 equals hello. It's gonna end up inferring it to be a string array. Yeah. But if you were to say, I mean, type A is constrained array of type of R3, like you're gonna get the right type there, right? You either have a string array or you have an array of string arrays, which is what we want. But like the minute you add another array into the mix, it's gonna be like, ah, shit. It unions that. Yeah. So we get T. So we'll have T or something like that, right? Oh, nice, dude. I love Ghosty. You type of our... See, that's what I thought, right? So let's say get rid of that guy for now, or we'll just leave it because we have it. If we do 0, what do we get? We get we get an array of arrays. Do 1. Like this should still bomb out. because we're still not like inferring. We need a way to look at the first index type to get the T, right? The T is not the type coming in. We want the first, hold on. I have an idea. Can we use pick? Can we say, hold on. Oh, Leo got something working. Input is an array of T or T. Input is type of R1. Mm-hmm. Okay. It's so, I mean, I think that actually works, which is weird because I thought that was the type I had originally. Like if we go back, wasn't that what constrained array was? That is the type I had. That's like the same type. So what did we do wrong? Get rid of that. Right. So now we need to take this one step further, though, I think. So this is really going to be like a homogeneous array. And then we have to take this type a little bit further. And we need to say, rather than this being like over here, we'll take that. We want to come in here, and the actual type would be like, it would actually end up being this, right? I think that's what we would want. Because like, yeah, so like the problem is, well, yeah, it does. Yeah. Yeah, I think that's what we're gonna have to do. So in here, we're going to say, that's a bummer that we don't get it for free out of this though, because we could then do something like, what would we do? We get our array, right? So we'll get by function to array, and we'll get our array. Yeah, yep. Let's go grab that. And that will be in source, index, yoink, use that as reference. Back over here, paste that there.
Functions describe the world.
I mean, I think it's useful for Melange FFI to deeply convert arrays to lists anyways. So we'll say this is value. If array dot is array value, we go into this branch and we say if the value is an array, no, that's not what we want. How is this going to work? Hold on. We need to map. We say value dot map to list. In the case that we get a not array, we return value. Is that right? No, we never convert it to Melange. We say this, melange.list of list to list, or of array. What is the, damn it. Oh, it must be array. Yeah.
Functions describe the world.
So down here, or where was that? Where were we working? We say melange array dot toList. And this actually needs to take an index. Really, it's index first. No, it's not. Is that right? So if we have an array, we map over the items in the array, and we say toList, and that's an array. We recursively do that. I think that's right? All right, let's go update the documentation on that. What? It's not technically a homogeneous array. It's like a homogeneous nested array. So maybe we build it up where a homogeneous array will be that, and then a homogeneous nested array would be something like that. Does that still work in our example? Oh no, I have caps lock on. Help, I'm stuck in Vim. Oh God. I can't tell what layer I'm on. Okay. Whew. That was scary. No. No. ¿Por qué? Ah, we need to block against this. We need the array to be all of the same type. So 3 should not be valid. And this goes back to us needing to, but this lets it. We still need to, it does not, unfortunately. Because it's inferring T to be string or number. Isn't TypeScript so fun? Maybe we can use extract. We could try that, right? We could say something like, where'd your playground go? Is it this one? Yeah. T, let's say, no, because it's going to union. We'd have to extend, like, we'd have to do, like, it extends. We would need, like, branches for, like, every primitive. But then you would also want to have, like, it'd be okay to have an array of no union. Is that a type? I mean, we could try, I think exclude and extract could possibly. Well, hold on here. Hold on here. We can exclude from T. Or what is exclude? Exclude takes the union type and the members to exclude. Okay, so we can just say array of any, right? We can be like, where did that go? I have too many tabs open. Is this it? No, where the frack? Exclude T, and then we would exclude array of any. And could that get us our first type. Never. Nailed it. We got string or number array. We're getting closer. Now let's try no. It's probably a cover of Counting Crows. So that's inferring as never. Yeah, this one doesn't accept any of the options. This is stupid. Get type of first element in array TypeScript. Okay. Show me the answer. There's no way, right? There's just no way. That's the type. Where was that? Is that? No. I've already lost what we were watching. T extends any, T extends empty tuple never. But that's okay for it to extend the empty tuple. Yeah, I thought I already tried that too. I mean, let's just T extends that never, otherwise T 0. Stringer number. That's literally R3 wrong. Literally wrong. Just always give me back X. What's this gonna do? Circular reference. We are going to win this fight, chat. I don't even care. This has to be possible. TypeScript is Turing complete. Of course it's possible. So this is still going to union everything. Yeah, string or number. Number or number array. I mean, we should effectively be able to do something like, we should be able to do something, where's my most recent one? Too many tabs. This looks great. Totally normal type system. Totally normal type system. Oh, this is why TypeScript developers need to feel what a real type system feels like, because this is not it. It does not need to be this complicated. Even the most complex things I've ever ran into in OCaml so far, like existential types and shit like that, way less hard to grok than this stupid thing. Yeah, I know. Oh, you were talking to BG, not me. Yeah, we're still going. We're fighting TypeScript. So I still think we can enforce that this extends that. And we can just do that to start. Type string another does not. Target allows only. Okay, sure. Okay. Type of. Yeah, we almost want like a type. Like I want to have that infer. Yeah, someone get trash in here for real. I mean, what if we. almost seems like, what was that? There's that library. There's a library that they were using for Type Hero. Um, oh, I don't have water anywhere. I gotta go get water. I actually think I'm gonna call it quits, y'all. I'm pretty tired and hungry right now. So, let's find somebody to raid. Leo, are you gonna stream right now? I have no idea what time it is. It's gotta be like mad early for you. Yeah, I was gonna say. Okay, let's go find somebody.
Functions describe the
We got
world.
Coppinger working on TypeScript. We've got Chris working on Wasm. We've got Spyro covering Pirate. Elixir. Oh, Ryan Winchester is streaming? That's not even a question who we're rating. Let's go. Am I not following him? Why is he not in my list? Let's go, chat. I'm so excited. I haven't been able to watch Ryan stream yet. Let's go. I'm so excited. All right, see y'all. I might stream tomorrow. If not, I'll be back on Monday. Love y'all.